Hi, my name is Matt Maxwell, and I'm a product manager for Tektronix Spectrum Analyzers. And today what I'd like to show you is a quick how-to video for doing EMI pre-compliance tests of a ZigBee device. ZigBee is a popular radio standard that's used in some Internet of Things devices, used for different devices when an internet connection may not be always necessary. Even if you're buying a pre-certified ZigBee device, there's final EMI compliance testing that'll be required, and in order to have a good assurance that you'll pass final EMI compliance testing, it's important to do a quick EMI pre-compliance check so that you have that confidence going into that test. So let's get started. So we're looking at a basic spectrum display, always a good place to start when you're checking for EMI pre-compliance. And if I wanted to, I could even apply a CISPR detector to that. If I go to the settings, and for traces, I do have a CISPR peak detector, which again, this is a worst case detector that as long as I pass the limit lines here, I know that I'll be compliant to the EMI standards. I'm just looking with it close into the band, not really the way that you'd use it, but that feature is available for some EMI checks. So let's do a few more detailed things that might be good to check for EMI pre-compliance. So going back to the settings, and here again we see the different measurement displays organized into different folders. I will pull up the spurious emissions test. So the next thing I need to do under the settings is load an Fcc limit line, which I have saved here in the user interface, or in my PC, FCC Part 15 for radiated for Class A devices, 10. So load that. And so what's already been defined here in the table are 4 different zones, and I can move this out of the way so we can still see the measurement. I have 4 different zones per the FCC Part 15 mass test. The start and stop frequencies, the CISPR shape with a plus peak detector, video bandwidth, and then some different thresholds that define first a spur and then define the limit lines for the test, which are here on the right hand side, absolute start and relative. So I'm failing the test, but I really need to redraw this limit line to exclude the ISM band, the 80 megahertz ISM band. But I have a couple of spurs on this device up at these higher frequencies which are a failure, and all of those are listed in the table which appears below the spur search. If I want, I can save the results here by going File, Save As, and I need to specify the file type, so I do results export CSV, so it's a comma separated variable table of those results. So one feature that's available there. So this is typically a test that would be done over a broad frequency range. You can see this is done up to 7.5 gigahertz for EMI pre-compliance. As long as I have the setup done correctly, I'm in some sort of quiet RF environment, there's not background noise that's interfering with this, then this should give me a reasonably good assurance that I'd pass the test. Now let's say you do have background noise, maybe from an FM broadcast in the lower portion of the spectrum. The way that you'd sort of discern that is you'd have to do a measurement with the device turned off and then one with the device turned on, and disregard the background signals that would be present if you don't happen to have an anechoic chamber or some other way to make a quiet RF environment. Another part of radiated emissions tests are to look close in around the ZigBee signal in this case. So the way that that's done is I'll pull up a spectrum emissions mask. So I go back to the RF measurements. This is, by the way, both these features are standard free of charge options or capabilities that come with our USB spectrum analyzers with SignalView PC. Anyway, spectrum emissions mask is what's frequently called for testing close in EMI limits. So the way this one's been defined, it's been set up already. Go back and show you the settings here. So I pull up the settings with this gear button for spectrum emissions mask, offset and limits table, and then expand that table. Pull this down here so we don't cover up everything. I'm only having one zone turned on now, so it's on both sides from 3.5 megahertz to 20 megahertz away, so from outside of the gray zone to the outer edges of the screen for this SEM, looking at both sides, 100 kilohertz RBW, and I could set different RBWs for the different zones with this measurement. And I have both the absolute and relative test that's called for in a lot of the ZigBee standards for the 2.4 gigahertz ISM band. And I see that I'm mostly passing. So that's what we see for the spectrum emissions mask. So here we've looked both at the close-in radiated emissions and the far-off from the center frequency radiated emissions for EMI pre-compliance testing for a ZigBee device. So hopefully that gives you a little better understanding of how to perform basic EMI pre-compliance checks, at least from the point of view of driving the test equipment. I thank you for your time.